Example number 7, adding some more steps in. Oh, look, I see a minus 5, so I'm going to add 5 to both sides. If I add 5 to both sides, I get x plus 4, still being squared on the left. But since I added 5 to the left, I add 5 to the right, and I get 36. Darn it, the x thing is being squared. I want to undo that. So I square root both sides. When I square root a square thing, that's a variable, I have to go with a plus or minus. So now I have x plus 4, but the square and the square root are inverses, so they undid each other. And on the right-hand side, I have plus or minus the square root of 36, which is really plus or minus 6. And then my last step, I think, is to move the 4 to the other side. So it's plus 4 here. To get rid of it, I would subtract 4 from both sides. So now I have x equals, and if I move it to the other side, one way to think about it is it now becomes negative 4, and then it's plus or minus 6. Now you are not going to leave your answer in that manner on your tests. What you're going to do is go, oh, hey, I get this. This really means that there's x equals negative 4 plus 6, which is 2, and negative 4 minus 6, which is negative 10. And those are my answers. In example 8, there's a 2 in front of the radical, so I divide both sides by 2. If I divide the left side by 2, the 2 in front of the radical is gone, so I get x minus 8. If I divide negative 20 by 2, I get negative 10. Now I want you to think about this. When can a square root ever turn out to be negative? Never. Never. There's no solution. You can't ever get a square root to come out to be a negative number. That's not going to happen for you. So if you ever see a square root equal to a negative number, you can write down no solution. It's not possible. A few more examples. In number 9, there's a 14 that we need to get rid of. So since it's being added to the parentheses stuff, we're going to get rid of it by subtracting. So I subtract 14 from both sides. If I do that on the left side, I'll have x plus 12, the quantity being squared. And on the right side, 35 minus 14 is 21. And then I see the square with the x stuff. I want to undo that. So to undo that, I'm going to square root both sides here. And oh no, I square rooted an x thingy, so I have to write down plus or minus. So now I have x plus 12 equals plus or minus the square root of 21. Unfortunately, I don't know what the square root of 21 is, so I'm just going to leave it. And then my last step is just to move the 12 over to the other side, and I end up with x equals negative 12, because when it moves to the other side, it changes sign, plus or minus the square root of 21. These are the two exact answers. You could actually, if you wanted to, type this in your calculator and go, oh, negative 12 plus the square root of 21. Write down a number. Negative 12 minus the square root of 21. Write down a number. Don't do that. These are the two best answers. Negative 12 plus or minus the square root of 21. Great. Leave it. Super stud mathematics. In number 10, we're dealing with absolute value, and remember, when you shove something into the absolute value, it's talking about a directed distance from the center. In this case, there's nothing with the x, that means the center is 0. So kind of the practical way to think about it is, what number could I shove in for x that when I shove it in, out pops a 9? 9 works,
Negative 9.
and negative 9 works. So the answers to example 10 are that your x could be a 9, or it could be a negative 9 that gets shoved in there, and out pops a 9. That's kind of what the absolute value does for you. Kind of strips away the negative sign. Now, notice how in example 10, what you saw inside the absolute value bars was either what you saw on the outside, the 9, or it was its opposite. You guys see that? What you saw on the outside or its opposite. Using that reasoning, if I look at example number 11, what I see inside the absolute value bars, which is the x plus 2, is equal to what you see outside, or the stuff that you saw on the inside of the absolute value bars is equal to the opposite of that. Remembering that there are two answers. You solve each equation independently, and you get your two answers. So in example 11, if I move the 2 over, I get x equals 3, or in other words, 3 plus 2 is 5. Or, if I move the 2 over this time, I get x equals negative 7, because negative 7 plus 2 is negative 5. And so the main difference between example 10 and 11 is there is something with the x on the inside. But the reasoning works exactly the same. Whatever you see on the inside of the absolute value is what you get on the outside, or what you see inside the absolute value is equal to the opposite of what you see on the outside. So example 12 is probably our most complicated absolute value version. And you'll notice there are a few things going on with it at the same time. So I see the minus 2 there, and I don't want that minus 2 there, so I add 2 to both sides. If I add 2 to both sides, I get 3 absolute value of x minus 5 equals, and I've added 2 to the right-hand side, so now I have a 12 on the right. Oh no, there's a 3 being multiplied by the absolute value, so I should divide by 3. If I divide by 3, I get the absolute value of x minus 5, because 3 divided by 3 is just 1. And then I divide the 12 by 3, and I get 4. So now number 12 looks exactly like we started out with number 11, just different numbers. And what that's telling me is that I have either that x minus 5 that I see on the inside is equal to the 4, or that x minus 5 that I see on the inside is equal to the opposite of 4. The big idea is that when you have absolute value, there are two answers, so you set it up that way. Add 5 to both sides on the left, and you get x equals 9. Add 5 to both sides on the right, and you get x equals 1. If you take both of these numbers one at a time and check them, you will see that you produce what you want. In example number 13, something kind of funny happens. If I minus 5 from both sides, I get the absolute value of x plus 2 equals negative 1. Very similarly to example number 8, where we had a square root equaling a negative number, there is no way in number 13 that you can ever have a negative being produced by an absolute value. So there's no solution because the absolute value can't produce a negative number.